All right, so if you've ever got something that's in standard form and you want to be able to graph it, or you just want to know what the slope of the line is, we often do that by converting it to y equal mx plus b. So we're just going to algebraically manipulate these variables so that it's in this form. Now, the key to having something in slope-intercept form is that y is by itself. Notice that there. That's what makes it in slope-intercept form. So that's all I'm going to do here is I'm going to take this and solve for y. It's a two-step process usually. We'll subtract 2x from both sides. That's going to give us, those will cancel, negative y on the left-hand side is equal to negative 2x minus 3. Right? And then I need this to be completely by itself, so I'm going to divide both sides by negative 1, right? Which is just going to change the signs on the right-hand side. Y is equal to positive 2x plus 3. All right, I need that because now this tells me what my slope and my y-intercept are. Slope is just that number attached to x, remember? All right, but now that it's like this, I could easily graph it, supposing I had graph paper. I would start off at positive 3 for my y-intercept, and then I could use my slope to go up 2 over 1. Right? Up 2 over 1, something like that. Down 2, left 1. There we go. And so this graph will represent all the solutions to that equation. All right, we'll do a couple more examples here. So we're going to take this equation and we're going to solve for y. Get y by itself. So it starts off, you move the x term over, so plus 3x to make that happen. All right, they'll cancel on the left-hand side. Positive 2y comes down. Now notice here, I'm not calling this 13x or anything like that because they're not like terms, remember? You got your x term and you got your constant term, and those do not get to go together. All right, we'll divide by 2. Divide every piece by 2. So it's going to be y equals 3 halves. That's how we'll handle the 3x divided by 2. It'll be 3 halves x, and then 10 divided by 2 will be 5. There we go. All right, go ahead and sketch a graph of it real fast. Starting off at positive 5 this time. And then I'm going to go up 3 over 2 for my rise over run. All right, up 3 over 2 is about right here, something like that. And then down 3, left 2, something like this. Of course, if you had grid paper, you could count all those little spaces. All right, I just want you guys to be familiar with mainly how to convert one, because this is going to be a pretty common practice, and how to handle the dirty looking fractions over here. All right, it was 3x plus 10 all divided by 2, and so I just did 3 divided by 2, and 10 divided by 2 was 5. All right, last one. All right, we're going to move our x term over, so subtract x to make that happen. That's going to give me a negative 3y on the left-hand side. Make sure you bring down that sign with it. And it'll be negative x, positive 9, and then we're going to divide each of these by negative 3. Divide by negative 3. All right, so this one, it's an assumed 1, so we're going to end up with a negative divided by negative, so it'll be positive 1/3 x, and then 9 divided by negative 3 is negative 3 again. All right, this is the key for figuring out what the slope and the y-intercept are for something that's in standard form, mainly the slope, because we talked about how to find the y-intercept last time. All right, we'll graph it. We're going to have negative 3. That's our y-intercept. And then we're going to go up 1 over 3 for our slope. All these had positive slope, didn't they? All right, up 1 over 3 is about right there. About right there. There we go. All right, and that is how you convert something to slope-intercept form.